Hello everybody, welcome. Today we're going to be doing some practice work, or not practice, we're going to be doing some homework. This is logic, so if you don't know anything about logic, then I guess this will just be a very entertaining video of me flexing my knowledge, or struggling immensely. We'll see. So let's start off, we're going to be doing, this is conditional proofs by the way. So let's get right into it. We have G or H. If G or H, then S and T. If T or I, then C and D. And our conclusion is if G, then C. Okay, so we have a G here. Okay, so what we can use a conditional proof potentially right off the bat and prove. Can we prove if G then C? Will that do anything? Well, I mean, it won't do us too much for that one. No, we can't directly prove this one. So we're going to have to think outside the box. So what we want to prove is C and D. And we can do that by using T or I. But we would need T. And we can use the addition. So what we really need is T. So, I don't know how conditional proofs would help right here. It probably will, but I don't know how. G or H, if G or H, then S and T. So, if we did G wouldn't really do us too much. G or H, that would give us S and T. And then from there, if G and H, then T, perhaps? If G and H, then T. Or I. Oh, and then we can do G or H. Okay, so let's try that. Right? Let's do G or H as our conditional proof. Then we'll do, and we'll see how this goes, right? G or H, and this is going to be, I do have a fan in the background because it's really hot, but yeah. So we have G or H. This is via ACP. Assumed conditional proof. So using that, we can get S and T using 1 and 3 modus ponens. So now that we have S and T, we can use commutativity to give us T and S, which is line 4 commutativity. Then simplify. Line 5, we simplify. Then we do addition and give us T or S. T or I, sorry. T or I, which is line 6 addition. So now we have ourselves, if G or H, I should probably do, if G or H, I'm struggling to type here, if G or H, then T or I, right? If G or H, then T or I. Using lines 3 through 7 conditional proof. So now we can get G or H. If G or H, then C and D. Via modus ponens. Does this give us anything? No. Sorry. This is line 2 and 8 hypothetical syllogism, pure hypothetical syllogism. Okay. If G or H, then C and D. How do we get from this to that? Well, in some way, we kind of have to prove... Is there some way that we can... Is there any type of rule that we can use to maybe make this possible? Associativity, perhaps? No. So we got to use one with... Exportation. No, it's not exportation. I'm stumped. I have no idea how to get from this to this. Like, obviously I could use... If I could prove G or H by itself... Because this is... Obviously with a conditional proof, you have to prove a conditional. And I proved a conditional, and that got us to where we are now. So maybe we need to do another conditional. Let me think. I'm really stumped. I have no idea how to go about doing this. Exportation might do something for us, right? Because we have kind of the setup for exportation. No, we don't. We don't have the setup for exportation. Yeah, I have no idea. Genuinely. I might have to phone it in, because I have no clue where to go from here. This one's hard. Number 4 is really hard. Alright, let me take a look and maybe get like a little bit of extra knowledge. Maybe that'll help us out. I'm also saying screw it, I'm going to get my fan because it's so hot and I'm starting to sweat. Wait, you can prove if G then C? Okay, so I'm looking at it, and it does say that you can prove if G then C, which is surprising. So, with that in mind, I haven't looked at exactly what we need to do, but what I do know is that we need to prove if G then C. So this method I did here is not going to help us. Okay. Really? So you can directly prove if G then C. That's surprising. Okay. Okay, well, I guess, yeah, we'll try that then. I'll say this is ACP. I thought we were going to use a hypothetical syllogism there. So, yeah, you could do G or H using line 3 addition. You can use... you could get S and T from that. Right? You can get S and T using lines 1 and 4 modus ponens. From there, you can then get T and S using commutativity for number 5. Then you can just get T. For simplification, then you can get T or I using... So, I mean, a lot of the stuff is seemingly the same, just the fact that we have a G now makes this possible. So, yeah, 7... and I didn't look at what I'm supposed to do, by the way. I'm just guessing here. Basically, I saw this. This is all I saw right here. So... From there, I'm like, oh, no, we start off with G? Okay. So, T or I, that's going to be addition. Whoops. So now we have C and D using lines 2 and 8 modus ponens. Oh, this makes a lot of sense, actually. Now you have just C, using simplification. Of line 9. And then there we go. We have, that's what we have. Lines 3 through 10. What is it called? Conditional proof. Alright, never mind. I'm just unable to see that kind of stuff. So can we do if C or B then A right off the bat, or no? I probably shouldn't. So let's just try C. Let's try C. Let's say assumed conditional proof of just line C. Now that'll give us A and D. I don't know why I put the parentheses around it. A and D, lines 1 and 3, modus ponens. Can A give us anything? A? Yeah, no. A and D doesn't give us anything. You know what? How about this? Let's try C or B. Let's try C or B directly, right? Let's try C or B. That's the assumed conditional proof. This is going to take extra steps, but we got this. So now we can both get C and B. That's what's going to be needed. All right. So now we have. Oh, wait a minute. It says right here, problems 11 and 12. Yeah. Okay. Hold on. C and B would help us, but not C or B. C or B wouldn't really be able to do too much for us, because we can't prove anything with C or B. Unless if we were also to assume C. Okay, let's do this the other way around. C, assume conditional proof, C or B. There we go. We're going to add on there. There we go. So now we have both C and C or B. Which is a step in the right direction, I imagine. Or maybe it's not, who knows. Or, how about this? C and B, then we can get C or B. So let's say C and B. So then we could get C and B by itself, right? So C and B. So we're going to have 3 simplification. Then we can get B and C by doing line 3 modus, commutativity. Okay. Now we have just B using simplification for line 5. Okay. So now we have both C and B by itself. So we can get A and D. Oops. A and D using lines 4 and 1, or 1 and 4, I suppose, 1 and 4 modus ponens. And we can also get A and D. What is this going to give us? It's going to give us if C and B, then something else. It'll give us if C and B, then A. Maybe we can give ourselves a setup, because C or B, if C or B, then A is our line, right? Maybe this can give us a setup to do something else, right? Like, can we do anything with this? Like, this is not going the way I expected it. A and E, because I can get D and E. I can get all of the letters by themselves. But at the end of the day, it's gonna give us if C and B, then something. Which is not the worst thing. Like, if we can get if C and B, then A, we might be able to MacGyver something out of that. If C and B, then... yeah, I just don't know if you could do anything with C or B by itself. There's not too much we can really do. I think what we can do potentially... man, I have no clue. Yeah, I'm gonna look it up. I have no clue. I don't even know where to start. What time is it? 9:59? I got an hour left. Yeah. Absolutely no clue. This one is really hard. Alright, I'm going to try and only look at the top. So this is number 10. Number 10. So C or B is the starting point, really. So the starting point is C or B. How is that going to give us anything? C or B, there's not really too much you can do, really. Let me think. Yeah, I mean, it makes more sense than all of this. No, I don't know, man. C or B. What can we do with C or B that will help us? I really can't think of anything. If we can somehow get not C or B, then we can use De Morgan's. But that's not very useful right now, is it? Like I said, I have no idea. All right, I'm gonna have to look further because I don't even know what the next step is. Number 10. What in the heck? How did we get from here to here? Hold up. Conjoining the two conditionals? Conjoining the two conditionals. Wait, hold on. That's unrelated, right? That's unrelated, yeah. Okay, so, all right. So we're gonna conjoin them, and I guess we're gonna use, uh, I guess we're gonna use distribution, maybe, or constructive dilemma. Ah, okay. That's smart. I don't know. I still don't know how that's gonna help us. So we're gonna apparently conjoin this. I gotta use this. So if C, then A and D, and if B, then A and E. Okay. And that's gonna do from conjoining lines 1 and 2. I wouldn't think that this would give us anything, but apparently it does. So now we can get A and D, or yeah, A and D, or is it and? No, it's or, because we used or for the first one. A and D, or B, A and E. And we do this because line 4 and 3 and 4 constructive dilemma. I did not, out of all the possible things, I was not thinking constructive dilemma. This is very weird. This is one of the weirdest proofs I've ever proven. So I imagine, based off of the setup, that we're going to be using some sort of so it's blank and blank, or blank and blank. Distribution, right? So we're going to have A and D or E, right? A and D or E. And that's going to be line 5 distribution. Because it's P... Well, we have P and Q or P and R. P and Q or P and R. So we have P and D or E. Distribution. Somehow this is going to give us A. Oh, because we can just do simplification. So line 6, A, 6, simplification. So now we have exactly that. It's going to be conditional proof from lines 3 through 7. That one was hard as heck. Wow. Yeah, okay. My brain ain't that big. I'm not that big brain. That was insanely difficult. Wow. Conjoining both of the proofs. That didn't even register in my mind. Okay. So if R then B, and if R then B then F, so there might be some association involved here. Let's see. Is that the association? Nope. Not association. What is this? Exportation. Right. No. It's not exportation. Or is it exportation? No, it is exportation. My bad. R and H. So we have if R then B, if R then B then F, and if B then F then H. So exportation is probably going to be a good friend of ours. So should I do the exportation first? R and B. If R and B, then F. If B and F, then H. Presumably, that's going to be inside of our conditional proof anyways. So can we prove if R, then H directly? Possibly. Well, what we need to prove is... if R, then H. Let's try it. Let's try if R, then H directly. Let's see if there's anything we can do to possibly get us there. So we're going to have our assumed conditional proof. Now, where do we go from if R, then H? If R then B and if R then H. Yeah, I mean, if we use... wait, I'm dumb. We're just doing this. That makes a lot more sense. I'm dumb. So we're going to assume R, and then... Oh, man, I'm glad I caught myself. So that's going to give us B from lines 1 and 4 modus ponens. Oh, my God. Wow. I was about to be really dumb. And then we can convert R and B, then F, which is going to be exportation of line 2, right? Is that correct? Yeah, because we have if R then B then F, and we export that to if R and B then F. If R and B then F. Yeah. Okay. So now we combine R and B, since we have those individually, using lines 4 and 5. Yeah, 4 and 5 conjunction. All right. F, which is good. We're going to get F. I see how this is going to go. I see how we're going to do this. Sorry, anyways. F, and this is going to be lines 6 and 7 modus ponens. Because we have if R and B, then F, and R and B, therefore F. So, this is then we got to do conversion of if B and F, then H, which is going to be line 3 exportation. Then we got a combined B and F to get B and F, which is going to be lines 5 and 8 conjunction. Then we get H using lines 10, 9, and 10 modus ponens. And then we get if R then H, lines 4 through 11, conditional proof. Right? Presumably. Let's see, let me double check and see. This is number 13. Oh, they did it in a lot less steps. Oh, they did it in a very interesting way. So they proved, oh, if B then F. Then they proved F. Then they proved H. F and H. H. Oh, that makes a lot more sense. The way the textbook did it resulted in 3 less steps, 2 less steps. Just did it. Yeah. Yeah. fine. That's just the way I did it. Alright, next up, number 9. Now, there is no answer to this one, so we'll see how it goes. I'll just do it, and then we'll figure it out. How many more questions are there? So 9, 11, and 12, right? Okay. Number 9. If H, then I, then N. If H, then not I. If H, then not I, then M or N, and Q or R. And our goal is T. Not if something then T, it's just straight up T. Okay? This one's gonna be interesting. Okay. How do we prove T? I mean, realistically, did I write this one down correctly? Let me just double check, because you never know. This one's weird. This one's really weird. I mean, I can do it, and I kind of see how I'm going to do it, but I just want to double check and make sure sometimes. So number 9 says, oh, it's not. We're proving M. Now that makes a lot more sense. Okay. Also, the last line is not N. Oh man, good thing I went back. So yeah, if H, then I, then N. Correct. If H, then not I. Conditionally M or N, not N. Goal is not, or is M. Okay, there we go. So this makes a lot more sense now. So our goal is M. Okay, so I know we're going to be using a conditional proof, obviously. So what we want to do is somehow get this M or N right here, right? But we also need to... So to get this, we're going to need to get H, if H, then not I. We can get H by itself, not I, we can get from this. So let's do conditional proof of H. Let's start off with H. So you can kind of see where my mind is going, right? So now we can get if I, then N, using lines 1 and 4 modus ponens. Now that we have this, we can... we can use lines 3 and 5. Modus tollens. I was going to say to get not I, losing line 3 and 5, because we have if I, then N, not N, therefore not I. And that's modus tollens. Now that we have how is this going to help us with our next step? We could somehow get if H, then not I. Or could we switch it around? Because I was thinking, could we do? How are we gonna get this? So we got not I using lines 3 and 5 modus tollens. This one's tricky. If H, then not I. If it was H or not I, or H and not I, then this would be easy. My mind also thinks too, it could be H and I, right? We could be doing H and I. right? So, like, imagine if we did H and I, if H and I, then N. Remember, our end goal is just M. It's not a conditional, it's just M. So, yeah. All we need to do is get if H, then not I. Let me look again. So we could get potentially we could use some material implication, right? But that's or though. But we can add not I to this though, right? No. Yeah. Yeah, we can. So we can just add H or not I. Oh no, because then it would be wrong. So we could do not H. How about we start with not H as our assumed conditional proof? Then we can do not H or I, and that's just going to be our addition. Not H or not I, and that's just going to be line 4 addition. Now we can, bada bing, bada boom, have H, if H, then I. If H, then not I, sorry. Well, what is that going to give us? That's going to give us some kind of conditional. What we really want to do is create in this segment here. All right, let's go back to where we started, right? What we really want to do in this segment is create if not H then I, which I think is what I did, right? Yeah, okay. So now that we have if H then not I, using lines 4 through 6 conditional proof, we could now prove M or N, because we have the conditional proof. So we have lines 2 and 7 modus ponens. I don't know why my mind didn't jump to that immediately. It's 11. Is it 11:19? No, it's 10:19. Oh, this is the correct clock. Yeah, I was gonna say because yeah, okay. And then obviously using lines 3 and 8 disjunctive syllogism, we can get M. Okay. Yeah, my brain was struggling and doing dumb stuff, but I got it. So, okay, if M then K then J, and it says right here that we're going to have to use one conditional proof embedded within another. Okay? So we're going to have an embedded conditional proof here. Also, this one looks wonky, so let me fix it. God damn it. Okay, so if M, then K, then L. In my mind, I'm immediately thinking exportation. Our goal is if M, then K, then J. Is that correct? Let me double check. This is number 11, right? If M, then K, then J. L or N. If L or N, then J. Yeah, everything looks correct. Okay, so considering that we're using an embedded thing, I'm tempted to say, M as our original conditional proof, as our assumed conditional proof. And then from that, we can get if M, then K, then L. So if we get if M, then K, then L, now what we want is if M, then K, then J. So our goal here is to get K, then J here, if K, then J here, and then after that, we're going to prove... Okay, let's just see where we're going, right? So we have if K, then L as our first proof, or as our first statement, using lines 1 and 3 modus ponens. If K, then L. Okay. What if we prove K here then? Now we have our assumed conditional proof. And then we can get J from this, right? Yeah, okay. Or I'll do this. Yeah. So now we have our embedded conditional proof of K. So assuming that K is true, we can get L using lines 4 and 5 modus ponens. Are you for real? I thought that was clear, but I guess not. So now that we have L, we can add on N, which is going to be line 6. Addition. Sorry, I was looking ahead in advance to see how this is going to get us anywhere. So now that we have L or N, we can get J using lines 2 and 7 modus ponens. Then we exit this little conditional proof thing, and we say if J then K, or if K then J, and we can prove that using lines 5 through 8 conditional proof. And then we can exit this and say lines 3 through 9 conditional proof. Alright? Because right here we have if K then J, so we have assuming K, let's assume K is true, we can prove that J is true. Okay, so now we have if K then J, so we have assuming M is true, we can prove that if K then J is true. So if M, then K, then J. So there you go. I'm going to assume that is the correct answer, considering that is the answer I got, and it is correct. The only way that it would be incorrect is if there is a better way of doing it, but I mean, I got it in 10 steps. That's pretty baller to me. Wowee. So this one only has one, no, line 12, right? Yeah, this one has one line for its proof. If A, then F, then if A, then H. Okay. So there could potentially be some exportation, maybe? Let's see. Yeah, it could be if A then F and A. Because, like, let's assume that A and F is G, right? Let's assume that's G. So, G, it's if G, then if H, then A. So, that could turn into if G and A, then H. And then with G would be converted back into A and then F. If A, then F, and A, then H. That might be what we're going to have to try and do, but we'll see, we'll see. Just because that I see an option doesn't mean it's the best option. Oh, that's a lot easier. I'll be honest, I didn't realize they could do that. Okay, so let's already start off with the automatic condition, or assumed conditional proof of F, just because it's a good place to start. Also, let me add another space here, because it might make it easier to see. It's kind of hard to see. So, assumed conditional proof of F, that'll give us if G then A, or G and H, using modus ponens for lines 1 and 2. So we gotta somehow get an A in here. And then convert that A into a primary function. This is weird. Let me look again. What is associativity doing? Associativity is not going to help with this one, okay. Let me look. Number 12. It is that is all correct. Yes. Okay. So we got to somehow get an H, which means we're going to have to use addition, like we have to, because there's no A in here anywhere. So we can give ourselves just G, using simplification of, or we can do F or A. Because right here's the thing. We're going to probably want to end up using not A, right? Because we could use, what is it called? What's the rule? Implication, right? We could use material implication. And so we could do if, I'm going to want to do that with F and H, right? So let's do G and H, sorry, H and G. Line 3, commutativity. This will give us just H. Well, I mean, what are we doing? We need to prove. We're going to be proving something at the end of this, right? If F, then something. So honestly, all of this, well, we need to assume F in order to get out the G and H, because we don't have any other letters to go with, right? So at the end, we're going to end up with if F, then something. But if we can convert that somehow into what we need, if F, then, right? Like, let me think. What could we possibly give us if F, then something? If F, then A? Like, we could potentially get if F, then A. Or if A, then F? No? If F, then... Because obviously we can't start off with the assumption of if A, then F, because that's not going to give us anywhere. It's not going to do anything for us. So we got to somehow magically make A appear. And at the end of all of this, it's going to be if F, then something. This one's wild. Yeah, because we could do H or A, H or not A, and then flip it around, and then we could get if H then A, or if A then H. Wow, this is hard as heck. Okay, so H. Let's try doing this. If H or not A, just because I don't know what else to do. Oh well, first we need to simplify. Simplify line 4. Now we're gonna have H or not A. The fact that I know we need to do addition helps us. So line 5, addition. Line 7, implication. Because that's what it is, right? If not, or it's not, hold on, what is it? Commutativity. No, implication. Not P or Q is the same as if P then Q. Not A or H is the same as if A then H. So at the end of the day, we can get ourselves if A then H. If F then A or H, you know? I just have to keep going back and double checking. Yes, that is indeed what the task was that was being asked for. If A then F. If A then F, then if A then H. I got ourselves if F then A or H. Now we gotta somehow shoe hammer in You know what we might need to do? If not F, then not A. Alright, let me hold this thought for a moment, right? Because this is getting us somewhere, maybe. But let me hold that thought for a minute. Okay, so let's go back. Let's start from square one. Let's assume, and once again our goal is this here, so let me copy and paste this. Okay. Let's assume if not F, and see what we can do with that, right? Because if we have if not F, because then we could get if not F, then not A. which we can then use equivalence, no, transposition to get what we need. So let's assume if not f, so then what do we get? If not f, no, that doesn't help us then, because we can't do anything with not f. Obviously, we can't use if A then F, because there's no A. If we could get ourselves a starting ground, then maybe we can prove something else. Like, what if we can prove if F then G? Or, if we can prove if G and H then A, then we can prove if F then A. Can we, like, convert this into something else more useful? I don't think so. Exportation. Because, yeah, I mean, the only way that we could do anything useful with this is if we did if A then F. Or A, if A then F and A is H. That's the only way we can do anything useful with that. But if we can prove... Can we then prove anything with this? If A then F and A then H. If A then F and A then H. No, I don't think there's anything we can do with that. Oh, man. Okay, so... My mind is immediately trying to think of anything we could possibly do to get us on the right track. Like, how are we going to get an A? We're going to get an A somewhere. Like, if we could prove if F then something else, maybe? If F then A? If we can prove if F then... Maybe we can prove if F then not A. And then... Like, we could prove if F then something. Or we can prove if G and H then something. Because this is it. We have to start off with either F or G and H. Those are the only two options, literally. That's it. So we can prove if G and H... Like, if we did not G and H, then we could say not F. If not G and H, then not F. Or... if F, then so we can get if G and H or F or A, or F or not A, potentially, right? Line 1, and 2 modus ponens, and then we can get F or A, because we're gonna have to somewhere in here. Can we do like if not A and H, then not A and F? That wouldn't be very useful, would it? Like, okay, so this one I feel like is clear. If G and H, so then we're gonna have to add an A in here somewhere. F or A? F or not A? If F, then A or H. How about this? How about this? How about this weird strategy? If A, then F is going to be our assumed conditional proof. Then we're going to assume A. And then we'll go in the same way that we kind of did it last time, where we have so then we can prove F using lines 2 and 3, modus ponens. So now we can prove G and H. Because with this we can prove if A then H. Right? So G and H, I'm thinking of the AOL sign here in my mind. Lines 1 and 4, modus ponens. And then from here, we can convert this into using line 5 commutativity, right? Because that's what commutativity can do. Yeah. And it's a rule of replacement, by the way. I could do it at any point, though. So now we can just simplify. So now we have if A, then H. Using lines 3 through 7. Conditional proof. And then we can just end it off with this, right? Lines 2 through 8, conditional proof. I think that's how it's going to work, because we're just going to say, okay, if A then F. if A then F, can we prove if A then F, then if A then H? Okay, well, let's assume that if A then F is correct. Okay, well, let's double assume that A is correct. So now that we assume that A and F is correct, and that A is correct, then we can say F, using modus ponens, 2, 3 modus ponens. Then we can get G and H, because we have F, using lines 1 and 4 modus ponens. Then we can flip them around and get H and G using commutativity of line 5. Then we can simplify that and get just H. So now using lines 3 through 7 conditional proof, we can prove that if A is true, then H is true. So now we have if A, then H. Oh, well, look at that. Now we can also prove if A, then F is true, then A, then H. Boom. That was, oh, it's good. That was tricky as, that was tricky. Tricky. All right. Well, that's it. Those are all of the homework questions. I will see you guys. Did I even do anything? I did not. There you go. I will see you guys later, and hopefully this has been informative and useful. And if it hasn't been, then, yeah, you know, that's just how it is. Sometimes I'm just not useful. And that's it. That's all I have to say. Goodbye.